Here are a couple additional practice problems for derivatives involving some trig functions. So let's take this one first. This one looks like you can use the quotient rule. You can always use properties of trig and make this tangent cotangent up top and use the product rule. I'm not going to do that. So the first thing though is realize here that 4 over 7 is a constant multiple. The advantage to that is it's a little bit easier and you won't have to do as much simplification at the end. Really what you're doing here is you're simplifying up front. So the derivative is the quotient rule. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom, secant squared, all over the bottom squared. I'm going to clean this up now. We have negative sine x tangent x minus cosine x secant x, secant squared x, all over tangent squared. Now what you can do here is think about your reciprocal trig identities and see if it would simplify. This tangent is sine over cosine, so this would be sine squared over cosine. This secant squared is 1 over cosine squared, so this would turn out to be 1 over cosine. So the denominators look like they're going to be very similar. I would go ahead and try to simplify here. If you left it as this, probably you want to factor out a negative. That would most likely be fine because I don't think the simplification is that obvious. But say you're going to go to Wolfram Alpha, you may see a much different result because they went through the simplification. So what I'm going to do is I'm going to factor out the negative. The top is going to be sine x over sine x over cosine. That's what tangent became. And this would be cosine x times 1 over secant, or cosine squared x. And this is still all over tangent squared. So I'm running out of room here. So I have negative 4 over 7 times sine squared over cosine minus 1 over cosine, and that's what I was talking about. We have a common denominator up there. And this is still all over tangent squared. So next, you have sine squared x minus 1 over cosine all over tangent squared. This looks pretty familiar. We know that sine squared plus cosine squared equals 1. If you forget that, you should start memorizing that again. That's just a Pythagorean identity. It's a very popular one. So that means sine squared x minus 1 equals negative cosine squared x if you just move your terms around. So this is negative 4 over 7 times negative cosine squared x over cosine. So that looks good. still all over tangent squared. So negative 4 over 7. And now this simplifies into negative cosine, this part. One of the cosines canceled over tangent squared x. Negative times a negative. So the last thing I'm going to do, since we did all that simplification, I'm going to see if this helps. Cosine x, we're going to bring the tangent squared up and make it cotangent squared. So I'm going to change the cotangent to, if tangent is sine over cosine, cotangent is cosine over sine. So my final answer is going to be 4 cosine cubed x over sine squared x. Hopefully I didn't make a mistake. What I'm going to do is check that on Wolfram alpha later. So there was a lot of simplification that was involved here. It might frighten you a little bit. At this point, though, if you got this answer, you're good. Some of this simplification, like when I use the properties of trig, I could have done right away and maybe have gotten to this point easier or quicker. In other words, I could have, before I started the problem, began like this. Actually, now that I'm looking at it, no, that's not gonna help me much right now because it's going to be cosine squared x, and we don't know how to differentiate this. We could use a product rule up here if we want, but then we have a product and quotient. So I'm going to abandon this for now. We're going to learn how to do something like this later, and just stick with this. So that went a little bit longer than I thought, but I think it's really worthwhile. And if you need to rewatch. My next video is going to be, we're going to figure this one out. So, see you then.